Good morning, everyone. I am Prasanna from ITLM. Now I want to give a small demo about what is object-oriented programming in Java and why we need the help of Java so far, and how the way the Java, what is Java architecture, and how the way the Java programs are compiled and executed. These are the things we are going to discuss in the today's session. So say first coming into this we have to discuss about object-oriented programming. Yes. So coming into the C, object-oriented programming, it is not a new term. Simplified way we have to tell this one is whatever the daily life situations. That means in daily life what are the things we are doing, these things you have to represent in a programmatic way so far. So that one we call it as object-oriented programming. So that's why it is not a new term. So let me give a simple example. If I want to make 1000 iPhone 5s mobiles, then what I have to do? No need to write the code for 1000 times. Only I am going to write the code once. Now for the 1000 iPhone 5s mobiles, I am making 1000 copies so far. So that kind of the way we have to do that. That means for that existing code, we are making the number of copies on demand so far. So that kind of the approach we call it as object-oriented programming. So here the main program will not be executed directly. For that program we are going to create an object, and by using the object we are executing the program. So that one we call it as object-oriented programming. So let me explain the definition here. See, it is an approach that provides a way of modularizing programming that which can be used to create small partition memory area for both data and objects which are to be used as templates for creating copies of such modules on demand. So that's why see the main program will not be executed directly. For that program we are going to create an object. By means depending on the demand how many copies are created, that many objects we will make. So that's why this one we call it as object-oriented programming. So this one we call it as object-oriented programming. Now see, coming into this we have in this what is the meaning of object. So general way if I want to say it as an object, a person I call it as an object, a place I call it as an object. So see, with respect to this, what is meant by an object here is, an object is a real world entity that which possess three characteristics known as state, behavior, and identity. So these three things must be there. So that's why an object is a real world entity. So what are the things we need to have? State, behavior, and identity. These three things are there. So that one we call it as an object. So see, what is actually the state, behavior, and identity. Assume car is an object we have. So what is the state of the car? Either moving state or parking state would be there. So that itself we call it as state. And next we have behavior. So we have the behavior as left turn, right turn, reverse direction. So something we have. So that one we call it as behavior. Identity, each and every car is going to have one unique registration number. So state, behavior, and identity, these three things are there. So that itself we call it as an object so far. Now see, coming into this, we have object-oriented programming features. So why actually we need the help of, what are the OOPS features we have? Those we are going to discuss now. Coming into this, see, OOPS features we have encapsulation, abstraction, inheritance, and polymorphism. These four are the object-oriented programming features we have. So what is encapsulation here? Encapsulation is just like we have to encapsulate the data. That means we call it as data binding also. So see, coming into this encapsulation so far, wrapping up of data and functions into a single unit known as encapsulation. So we have to bind the data to the existing context. So that itself we call it as encapsulation. And next we have here is abstraction so far. Abstraction itself we call it as data hiding, because all the data I am not make it visible. Some part of the data I have to hide. So that hiding thing will be coming under abstraction. So we have, see, hiding the irrelevant details of an object that do not contribute to its essential characteristics known as abstraction. So that's why both encapsulation and abstraction, both the things will exist side by side. Simple example let me give for encapsulation and abstraction. Mobile is there. So mobile will have n number of features, but all mobiles will not have all the features. So depending on the context, some of the features are enabled, some of the features are disabled so far. So that itself we call it as encapsulation and abstraction. So that's why we have, see, encapsulation focuses on showing the relevant details, where abstraction focuses on hiding the irrelevant details. Both the things are existing side by side so far. Next we have here is inheritance. So what is the purpose of inheritance is, see, deriving a new entity from already existing entity known as inheritance. So through inheritance we can reduce the size of the program. So without writing the code again and again, once the inheritance is there, from that we can reduce the size of the program, because already existing thing I am inheriting so far. Simple example for inheritance let me give. You earn 1 crore, your father earn 1 crore. You are the only children for your father. Then you will get your amount, and as well as you are getting your father's amount also. So there you are inheriting your father's amount so far. So because, see, without writing the code, already existing thing we can reuse it. So the reusability we can ensure with respect to inheritance. And next we have here is polymorphism. So polymorphism, it's a Greek word, because it's the main purpose of polymorphism is, see, the ability to take more than one form known as polymorphism. So one entity, it would be available in different forms. So that itself we call it as polymorphism so far, fine. So the best example for polymorphism is humans are the best example for polymorphism. So how humans are best example? See, right now you are student, but you will not be in the student for 24 hours. So in you a student is there. So you are working somewhere, then you are an employee. you are participating in some games, then you are a player. At the end of the day, you are a family person. So in you, these are the different polymorphisms you have, isn't it? So that itself we call it as polymorphism. So one entity available in different forms. So that itself we call it as polymorphism. So these are the object-oriented programming features we have. Now next coming into this we have here is what is actually the class and why we need the help of class so far. These are the things we have to see, because up to this time we are going on theoretical basis, but let us see the things called what is the class so far and as well as why we need the help of class there. These are the things we will see. So coming into this C class so far, we call it as C. A class is a template or blueprint that which contains combination of data members and member functions, and members of the class can be accessible by using the instance of the class. So you can access the members of the class by using the instance only so far. So the instance itself we call it as an object. So see how the syntax for class here. See, we have class, class name we have, and in this we have data members and as well as member functions, both we have here. Fine. So this is the way we have. So class contains combination of data members and member functions. Now next coming into this is, so this is up to object oriented programming. Fine. And next we are going to see here is why actually we need the help of Java. What is Java so far and why we need the help of Java, and what are the Java features, what is Java architecture so far. These are the things we are going to see here. So see, coming into this C, why actually we need the help of Java. This is the first question I have. See, by using a C language, you can create a compiler, but why we are opting for C++? Because the reason is, if the code exceeds more than 25,000 lines, the compiler will not perform properly. And for everybody, it is very much difficult to write more than 25,000 lines of the code. So that's why instead of implementing this traditional approach, we are going with respect to this object-oriented programming. So that's why we implemented with C++ so far. But coming into this C, what is the drawback in C++? We are migrating to Java. So the first thing we have to see here is it's a platform independent, and as well as, because see what is platform independent means, Java programs are programs that can run on any environment without changing the source code. Like see, I am writing a Java program in Windows operating system right now. So the same program, if I want to run it in Mac system or Linux OS, without changing the source code, it will work. So that's why these programs can run on any environment without changing the source code so far. Fine. So that itself we call it as platform independent. And next we have is, what are the different applications we have in daily life is, we have console applications and as well as we have Windows applications, web applications, service oriented applications. So all the things we have. So all these kind of the things actually we can implement with respect to this Java so far, because the common language that which allows you to implement any kind of application that we will do with Java. And apart from that, another thing we have here is we have the concept called packages. So what is actually the package and why we need the help of package? These are the things we have to see now. So coming into the C package, contains group of classes that which belongs to one common group. So contains group of classes that which belongs to one common group. Now why we need the help of package here is, if you want to overcome the naming conflicts between classes, for this we need the help of packages. So see how the way we are working or we are dealing with respect to packages here is, let me take it out. See, so here I have, see, Scott is a class I have. So Scott is a class I have, and as well as James as another class I have. Now Scott class is having one derived class called Java there, and here also I have another thing called Java. Now if I create an object to the Java class, which one will be called? Either Scott's Java class or James Java class. So there is an ambiguity we have. So this kind of the ambiguity you have to overcome. Then we need the help of package. Because let me give a simple example. Assume that my project contains 3 modules. I gave the 3 modules to 3 different people. Now whatever the modules are executing fine at their end. But whenever I am trying to integrate these 3 modules into a single entity, I am not able to do that. What is the reason behind that is, whatever the class name is used by one person, the same class is used by another person for a different purpose. So that kind of the level ambiguity we have to overcome. So that situation we need the help of packages so far. So put them in package. So this one, let me put it here as package P1, and this one let me put it in package P2 so far. Now if I give P1.java, then Scott's Java class will be called, and if I give P2.java, then James Java class will be called. So this is the way we have to make it out with respect to this. So now next we have in this is, so we discussed what is Java and as well as why we need the help of Java. These are the things we discussed fine. And next we have is what are Java features. So we have simple, object oriented, compiled and interpreted, scalable, distributed, and as well as secureable. So these are the different Java features we have. So first, see, coming into this, what does this mean? Simple means, see, we have Java programs are programs that which are implemented by using simple C and C++ syntaxes. As programmer, no need to take care of internal details of Java like memory management, etc. as how much memory allocated to run the program. The same amount of memory will be reallocated automatically, because we have a feature called automatic memory management. So programmer no need to take care of the internal details of Java to release the memory and all. So that is with respect to this simple so far. And next we have in this is object oriented. So what are the object oriented programming features we discussed? All the things are very much supported by Java. Java supports all object-oriented programming features as it's a purely object-oriented programming language. So Java supports all object-oriented programming features. Now next one is important feature we have is compiled and interpreted. So what is this compiled and interpreted means? See, any program will be either it is compiled or interpreted, but whenever it is coming into this Java so far, at first it is compiled first. See, Java programs are compiled first. So as soon as compilation, see what will happen is during compilation at first it is converted into bytecode. So during the compilation at first it would be converted into bytecode. Once it is there in bytecode, now then dot class file will be created. So Java code after compilation it would be converted into bytecode format. But see, once it is in bytecode format, only the Java environment will understand with respect to this. But if any program needs to be run, the CPU needs to understand that. So any program that you want to convert into CPU understandable format, here the question of interpretation will be coming into the picture. So that's why during interpretation it reads the bytecode line by line and interprets. So during interpretation it reads the bytecode line by line and interprets so far. So that's why compilation level the bytecode will be created. So in the interpretation level automatically the execution will be taking place so far. So that's why the Java programs are both, it would be compiled and interpreted. And next we have here is scalable. So already we discussed this one. So platform independent things we discussed. So this again we call it as scalability. So what is this scalability? Is the ability to run the program without changing the source code. So ability to run the program without changing the source code. So here what will happen is, see, Java programs can run on any environment without changing the source code. So without changing the source code, they can run on any environment. That itself we call it as scalable. And next we have here is a distributed. Java supports in implementing all distributed applications. Like you can make web applications as well as service oriented applications by using Java. Like, see, because nowadays what are the things we'll have? We have web applications and as well as services we have, because services never executes of its own. whenever the services are running, different people from the different locations, they are going to access the applications, and as well as they are going to make it out. So that's why by using Java we can make service oriented applications and web applications so far. So next we have here is security. So what is, because security is a key thing for any kind of application. So security you have to make. Then see, different in Java applications are coming into this. There are different levels of the security we have. See, Java supports different levels of security as compiler level security, bytecode verification, class loader security. So like that, these are the things we call it as level 1, level 2, level 3. So like that, these are the different levels of the security we are making it out. So like, see, we have Java supports this, because in the compiler level security, whether your code is authorized to compile in the current environment or not, those kind of the things we do there. And next we have is bytecode verification will be coming at interpretation level. That means you can, because sometimes what will happen is, I wrote a code and I wrote a Java program. That program needs to run in your system. So then the security exceptions are coming with respect to this, like it will not identify your bytecode or it will not interpret. Those kind of the things will be coming in bytecode verification security. So class loader security is whether your program is authorized to run in the environment or not. Like the runtime loader things will be coming under this class loader security. So like that, these are the different things we have. We are going to discuss those things in detail, but I will show you where actually the security is coming into this. Anytime please open your command prompt, and as well as please type the command called policy tool. So if I type this command policy tool, then you will get a window here, see. So this is the thing we have. Now in this, see, if any kind of the security exception comes, then what is the job you have to do is, you have to click on add policy entry and as well as add permission. So once you do this add permission, it will ask what kind of permissions you want to give in this. I want to do the different permissions like all permissions as well as audio permissions, like see, different permissions we are having. So whichever the permission you want, those things you can specify. But instead of that one, if you want to give all permissions, please give here as all permissions and click on OK. Now this file actually you have to save it as .java.policy. So click on file, save, and in the default place, because see right now I am in users and prasanna, that is the default directory I have. In this you have to save this file with .java.policy. You have to save with file as see, save the security file with name as .java.policy, because then only the policy tool file will be identified by the Java environment, otherwise it will not be identified. So that is the way you have to store it. Now after that, see, we have, I am not saving this one because already I have these things. Fine, let me close this. So these are, so this is with respect to this Java features. Now see, next we have is what is the Java architecture, why we need the help of, what are the different components are there, and how actually these things are so how actually the Java programs are compiled and executed. These are the things we are going to see right now. So first C we have is Java architecture. So what are the things are there in Java architecture is Java file, Java class file, JVM, Java API. These are the things we have. Now coming into this C, we have what is Java file C. See, Java file is just like, say, we have Java code, Java program, which we are writing, Java program which we are writing and saved with extension .java. That means what are the Java program file we are writing, and as well as that which is saved with extension .java, that would be coming to Java file so far. And next we have is Java class file. So Java code after compilation, it is converted into bytecode. So this bytecode will have extension .class. So this Java class file will have the extension .class with respect to this. And essential component for Java we have is JVM. So JVM stands for Java Virtual Machine. So Java Virtual Machine will be the key component. By means one of the core and essential component for Java environment is JVM so far. So why we need the help of JVM? So if you want to process C, JVM is responsible for C. It is going to perform the operations as debugging, exception handling, security, and as well as version support. These are the things are taken care by the JVM so far. So how actually this debugging means? So the Java code, whenever we are write any program, JVM is going to convert that into this bytecode. So that is the debugging level will happen. Now next coming into this is exception handling. How the way we are going to handle the errors at runtime. These kind of the things we are doing with respect to this exception handling. So how the way we are handling the runtime errors, these are the things we do in this. And next is security. Already we discussed the security things. And next we have is, what is this version support? Version support ensures whenever we are running the lower version Java program, like see right now we are dealing with JDK 1.7 something, but if I have one program, JDK 1.4 program is there, that one if I want to run it in 1.7, so what are the support files are there? Those things are added automatically to the current environment. That means lower to higher every time it is possible, but higher to lower it is not possible. These kind of the things are taken care by the JVM. But if you want to do these kind of the things, what are the main things we have in this is, what are the components we have? So components of JVM are, we have class loader, JIT compiler, execution manager. So these are the three components we have. So what is the purpose of class loader? See, class loader purpose is used to load all classes which are required to run the program. So there are two types of class loaders known as primordial class loaders and class loader objects. So these are the two types of the class loaders we have. So what is the purpose of primordial class loader is use it to load all system classes which are required to run the program, because sometimes what will happen, I need to load some of the package classes or system classes. So these kind of the things we will load with respect to primordial class loader. And next we have is class loader objects. Use it to load all custom classes which are required to run the program. So whatever our programmatic classes, custom classes are classes which are written by the user. So these are the things we are making it out. And next we have is JIT. So what does the word JIT stands for is just in time. So what is the purpose of JIT compiler is converts the convert the bytecode into CPU specific code. So why we are calling this as JIT? Because the name itself says, see, for suppose in my program I am using some system classes or some package I imported. Now a package contains thousands of classes, but JIT compiler will not load all the classes. So in your program, which classes are required to run, only those classes will be loaded into the memory. Remaining classes are not loaded. So that is the purpose of JIT so far. So JIT is used to convert the bytecode into CPU specific, and for that program execution, which are the classes are required, only those things it will load, because then the execution becomes faster. And next we have is execution manager. Contains queue of programs which are ready to execute, where we can run the program. And see, before execution it needs to undergone security authentication. So after the security authentication only it is going to run with respect to this. And next we have Java API. Is basically it is an environment where we can execute Java programs, because this is actually we call it as API. As soon as the API support is there, then only we are going to run those things. So this is about this object oriented programming and Java architecture. And next lecture we are going to see about data types and how to write the simple Java programs in Eclipse. These are the things we are going to discuss. Thank you all. We will meet in the next lecture.